and energy are interconvertible. That means you can convert work into energy and energy can be transformed into work. There are so many examples like fossil fuel energy, petrol or diesel can be converted into work, that is car is moving. And when work is there, energy can also be produced. So work and energy are interconvertible. There is one more thing, that energies can be transformed from one form to another. And according to law of conservation of energy, we have a statement that it states that energy remains conserved, means constant. It can neither be created nor be destroyed, but it can be transformed from one form to another. The simplest transformations. I am doing work on this ball. This work gets converted into gravitational potential energy. Then it converts into kinetic energy of the ball. This is simple conversion of work to gravitational potential energy and then to kinetic energy. Let us see. Then when you are, this is slingshot. When you are pulling the rubber of this slingshot, it stretches. Why it stretches? Due to elastic potential energy stored in this. Now, when you leave this rubber of the slingshot, the stone moves. It gains kinetic energy. So, you are doing work, then it gets converted into elastic potential energy and then to kinetic energy of the stone. See here, in pole vault, this bamboo, due to twisting, due to bending, this bamboo is converted, that is elastic potential energy is converted into kinetic energy, and with the help of this one, first gravitational potential energy, then again kinetic energy, and this is due to elastic potential energy of this wall, this pole. See here, if we are lifting one stone up to this height, we are doing work to lift this stone up to this height. This stone gets potential energy, gravitational potential energy, and when you leave this stone, the gravitational potential energy gradually changes into kinetic energy, and at the bottom, just before touching the bottom, that is ground surface, this stone is, that is the energy, gravitational potential energy gets converted into kinetic energy. Larger the height, larger will be the potential energy, and the greater will be the kinetic energy with which the stone falls. This is the conversion or the examples related to elastic potential energy. Elastic potential energy. See, if I am stretching this rubber, my work is stored in this rubber in the form of elastic potential energy, and when I leave it, it changes into kinetic energy because it tries to regain its original shape. This, I am stretching it. My work gets converted into elastic potential energy of the spring, and then I leave, it tries to regain its original shape. One more example. See here, when I am twisting the spring inside this bell, this is the spring inside this bell. So when it moves, the energy, the work done gets converted into elastic potential energy of the spring, and that gets converted into sound energy. When the shape of this thing changes, I am compressing the spring here, and when I leave, it moves. Why? My work gets converted into elastic potential energy of the system, and then it gets converted into kinetic as well as potential, and then it falls down, the whole conversion of kinetic energy. See here, rubber band or the stretching or compressing of spring, this is all due to elastic potential energy. Example of bow and arrow. If we pull this string of this bow, that work done by this man gets converted into potential energy, and when he leaves it, that arrow moves due to the elastic potential energy stored in bow. Have you seen the toy car by which you wind the key? This is car. And when you wind the key, this is the spring, fully wound, here, the fully wound spring. And then when you leave the key, the spring unwind itself, the unwinding. This is the loss in potential energy, and due to this continuation, this moves and gets converted into this elastic potential energy of the unwinding spring gets converted into kinetic energy of this toy car. So there are so many applications in which we are using the conversion of elastic potential energy into here, like this sound energy, or when this toy is jumping, the kinetic and potential energy. So many things, so many applications are there. And then we will move to power. If work is there, if energy is there, we have to discuss power. When we discuss about power, suppose you want to cover distance of 50 kilometers from here. You have so many options. You can go there by car or by bullock cart. Which will you choose? Of course, car. Why? Work done is same. Bullock cart, that is due to force applied by bullock, is also covering 50 kilometer distance, and the car is also covering 50 kilometer distance. Then why you are choosing car, not bullock cart? Same work is done because force is same, displacement is same. Only the thing is the time taken. That means one more important factor is here, and that is time. Power is defined as rate of doing work or rate of transfer of energy. It measures the speed with which work is done, and that is very important for us. Nowadays, we need speed to do same work. Power is equal to work upon time. आपने ब्रेकफास्ट लिया, आपने काम शुरू किया, सुबह से जब आपने काम शुरू किया तो you are very fast, and then शाम होते होते लास्ट पीरियड आते आते you are exhausted. Why? आपका पावर क्या हो गया? कम हो गया. That means power depends on work done, of course, but it depends on time also. If you do same amount of work in less time, you have larger power, and if you take longer time, then the power is less. Let us find out SI unit of power. Since the formula is rate of doing work means W upon P, the SI unit of W is joules and the SI unit of time is seconds. So it becomes joule per second. To honor scientist Watt, James Watt, we give the SI unit of power as watt. So the SI unit of power is watt, which is of course equal to 1 joule per second. There are other units of power also, and to measure a bigger unit, that is the larger power, 1 kilowatt is used, which is equal to 1000 watt, 1 megawatt, which is equal to 10 to the power 6 watt, and 1 HP, that is horsepower, that is equal to 746 watt. Let us define 1 watt, जैसे हमने joule को define किया था. So 1 watt is the power of an agent which does work at the rate of joule per second, 1 joule per second. We have discussed just now that when you start a day, you are very fast. You are doing your work very fast. But as the day comes to an end, your power gradually decreases. That means you are not having same power from morning till evening. So what is the option for that? Let us calculate average power. Average power means the power of an agent may be doing work at different rates, at different intervals of time. That's why the average power is used, which is total energy consumed per unit total time taken. Whatever amount of work you have done in whole day and the time taken, and that gives you your average power. Even to calculate electricity bill, we have used units, 1 unit, 2 unit, 150 units. So that is the commercial unit of energy. For the bigger unit, as joule is very small unit, we use kilowatt hour. This is the unit of energy. Let us calculate what is the value of 1 kilowatt hour? For 1 kilowatt hour, 1 kilowatt into 1 hour. That means 1 kilowatt hour is the energy used in 1 hour at the rate of 1000 joule per second. So this is 1000 watt. How many seconds are there in 1 hour? 3600 seconds. So it becomes 3.6 into 10 to the power 6 joule. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. We use electricity in households, and that electricity is measured in terms of this kilowatt hour. So the energy used in households, industries and commercial establishments are usually expressed in kilowatt hour, and when you use 3.6 into 10 to the power 6 joule of energy, then it is equal to 1 kilowatt hour, and that 1 kilowatt is equal to 1 board of trade unit, or you can call it 1 commercial unit or 1 unit of electricity. So when we consume 1 unit of electricity, accordingly at the rate particular decided by the MPEB, your bill comes. So this is the bigger unit, or you can call it the commercial unit of power, energy, and that is energy is measured in 1 commercial unit, which is equal to 3.6 into 10 to the power 6 joules.